Hi, glad you joined me. This is the third video dealing with the continual problem with my Newell 625 Cat. We've now got results. If you're coming to this video without seeing the first two, I'd recommend you see them. There may be a fourth, depending upon what more I can learn, but I think I can make a pretty good conclusion and bring up most of the technical points right now. First, and this is true for all pusher type RVs, these types of vehicles are custom made by the factories, and these factories are in general small production number factories. One of the things that's happened since I did the first video is a lot of people have contacted me and said, yeah, they also are dealing with problems much like this. Some of them with brands that had bigger numbers. And on occasion, what they'd say is that for some unknown reason, their coach had a modification in that they may have had too small of a piece of ductwork, or the wrong ductworks, the wrong elbows, and that when they went to deal with the issues, they found the correct system needed to be reinstalled. They don't know how it happened. They guess at the factory they ran out of parts. In this particular case, since all of the data that I've received from other owners, there's a couple of things that have held up. One is that all of the 625 ACERT, and by the way, all these 625 horsepower engines are ACERTs, all of them have the same issue, and that is there is a stainless steel pipe connecting from the turbo feed up to where the air filter, normally this air filter would be turned around and would feed to the bottom. That one pipe coming through is a 5-inch stainless steel pipe. It looks like it's formed on an automated mandrel machine. It's a nice pipe. It's just seriously undersized. All of them have had a bung welded onto them so that you could place some kind of sensor like a filter minder on it. No one else has told me they have a filter minder mounted on that position, which is where mine was mounted, and which is where I saw the very low pressure there, essentially the high vacuum. One of the gentlemen talked about it looked like his had been mounted there, but then was later mounted to the filter, and he had never seen a high reading on it, which makes sense, because if the high turbulent area is at the beginning of the 5-inch pipe where it converts to a 7-inch, that would make sense. If you look at the first two videos, we talk about it, that 5-inch pipe was not properly mounted into the rubber boots. So no matter what you do, reading the pressures here when this is open to the atmosphere, relatively well open compared to the rest, you would not see a high vacuum. Most other people simply didn't have a filter minder. So one of the things I'd recommend while we're starting on this is that if you have one of these engines, put a filter minder on the elbow. And I'd like to hear back from people. One of the gentlemen who has an elbow and who had the filter minder on his filter had taken the 5-inch elbow off, and inside you could see that the rubber boots were poorly fitted. The pipe had extended into the rubber boots. I think what had happened was Newell went to a company that makes these stainless pipes. They're not easy to cut. They look like petrochemical types of pipes. And rather than trim them to the proper length, they decided they could just shove the boot in as far as it could go, and the whole thing would run accordingly, and they never bothered to go back and fix it. This issue has come up, I'm sure, with Newell, because when I brought up my issue with seeing 25 inches with a new filter, they just said, well, just count the miles. So if you have one, by all means, put a filter minder in the middle and watch it. I'd like to hear back from you as to what other people are getting. At the point where you then have a reading, you understand what you're getting. If you see a high reading, of course, I would recommend the next step to trim that 5-inch pipe back to get a proper blend into the elbows. The other problem we had, which was water entrainment, which is actually quite a bit more dangerous, really needs to be fixed, and you can do that a couple of ways. One is that you can put a scoop here. Newell had done that for the last few coaches that were produced with the Cat engine. They say the company that made the scoops are no longer in business, so you can't get them, but it was a nice scoop. It had a way to dump the rain out the back of the scoop without entraining it into the intake. And if a splash happened from a passing truck, of course the outside of the scoop was there to protect it. Since that's not available, if you want to keep the intake point where it is, then there is a pre-filter produced by Donaldson. They make two versions, and one is for the 7-inch pipe, which is what comes with it. And the problem is it only passes 1,400 cubic feet per minute. They make an 8-inch, which will pass 1,500 cubic feet per minute, but that still leaves you about 180 cubic feet short of maximum. Let's see if I can find that number. I'm not seeing it. Anyway, I'll try and find it and put it on the back end. So, the air intake is just one part of it. And luckily, the results of our test, we've just done 3,300 and some odd miles from Phoenix. Right now we're in the Florida Keys. And our highest reading has been 12 inches of water column. So we've gone from 25 to 12, and if you remember the discussions in the past videos, I think 12 inches was an area we were hoping we could hit. If we assume that the filter has given us 5 inches of vacuum, then we're looking at an additional 7. We know you start out automatically pretty much with 2. I've added quite a bit of piping here with some extra elbows. 12 is fine. The engine performed really well. We were able to pull 75 miles an hour on almost all of the road. We did not get onto some of the worst of the hills that I wanted to get to. I didn't take the northern route through Flagstaff and get that long 6% grade, but I did hit some reasonable grades coming through Texas and New Mexico. We saw the 12 inches of vacuum at about 617 horsepower. Where we saw it was when the coach going up a hill downshifted into 11th from 12th, and as it began to accelerate, when it got to right about 1,740 RPM, it shifted into 12th. Just before that point is where we hit maximum vacuum. Now, these engines, there it is. These engines hit maximum horsepower between 1,700 and 1,800 RPM. So, and they also hit maximum boost, 49 pounds of boost at both 1,700 and 1,800 RPM. So the fact that we saw the shift at 1,740 is pretty reasonable. Now, is it possible we could get a higher level of boost or a higher level of vacuum? Well, we would have to continue up that curve. It might be possible that on a slightly steeper slope that could be delayed a little bit. We could add another 10, 20, 30 RPM, might see another inch of vacuum. If we could get on a dyno, then we could do for each gear, we could essentially pull a curve and then we would know. But because the engine has been set up, in this case with a 12-speed ZF transmission, I think this is pretty representative of the top of the line. 75 miles an hour is the limit to my tires. The coach will actually do about 90. But it's not going to do 90 going up any significant slope. So the most that could happen is in 12th gear we might get closer again to 1740. But I think that puts us way past 90 miles an hour. I have to check. But even so, unless you're really lugging the engine, you're loading the turbos, you're not going to see the boost, or you're not going to see the vacuum. Anyway, I have a fairly high confidence that that 12 inches of water column with the 12 inches of vacuum is pretty representative of where we're at. Now, I read that off of what essentially is a Bluetooth vacuum gauge. And here, that program is on this little device, this little iPod. Now, I put it on a big iPad, but the typeface was so small that I couldn't read it. So this, at least I can hold close and I can see it while I'm reading it. Now, the Bluetooth is only transmitting once every second. It has to transmit to my device, and the program has to calculate from that and give you a readout. So it's very well possible that there's a plus or minus in there of maybe an inch, sorry. But for the most part, I got a lot of good data from it. The other thing that I used was the Blue Fire. So this is one of the windows I developed. This isn't the one I actually used. I use a simpler, let me see if I can pull that one up. If you're going to try and figure out your problems with these engines, then you have to become aware of how they operate, which means you need to watch. And in this case, what I'm watching is oil pressure and oil temperature, water temperature, RPMs, boost, and then intake temperature. Between all of these, I have a fairly good idea of how the engine is operating. In general, I've seen cooler temperatures, I've seen greater boost, and I've certainly seen an overall increase, especially at certain RPM ranges. Now, as summer goes on and we get into hotter and hotter climates, I'm expecting some of these results to change a bit. But I'm building a kind of a little database in my head of how this coach operates and just what it is that I fix. Now, it may be possible to do a partial fix. I have worked on more of a total fix. What I've done is I've gone in and starting at the 6-inch inlet for the cast aluminum feed pipe that goes to the turbo, I made it up a 6-inch, I think it's a 23-degree rubber boot. That's 6-inch to 6-inch. There's a 6-inch pipe about 10 inches long that then goes to a 6-inch elbow, 90-degree elbow, then goes to a 6 to 7-inch elbow, and then the 7-inch into the filter. On the other side, on my feed side, I have two 45-degree elbows that bring the air in from here So this is a 7-inch pipe, same as the other 7-inch pipes, and it's insulated with a 5/1000 piece of aluminum foil with an air space and a Dacron spacer, and then it terminates in a what you might call an air boot. This is an important feature. I wanted to bring this up. There is a document that Caterpillar has on the web. It's called Application and Installation Guide for Air Intake. It has a catalog number of LEBW 4969-07, and it is a generic air intake instruction manual, if you like. They give most of their instructions as if you were installing a generator in a building, but it all counts. It's all the same theory. The problem, of course, with RVs is that we don't have the room. We cannot use optimized pipes. A proper pipe to bring air into the turbo and keep the velocities of the air down, which Caterpillar has stated is 2,000 feet per minute. In order to do that, you need a 12.5-inch pipe leading into it. So we have enough room for 6 now. I'm thinking if someone's inventive, you might get a complete 7-inch in there. Now, something else I need to talk about is that this period of time, Cat was making changes. The next year, in 2007, now this is a 2008 coach built somewhere at the end of 2007, but it has a 2006 engine, which does not have the regenerator and does not have DEF. The next year they added a lot of other features, and of course they got busier and busier. So all of this setup, the pipes and all that, changed. So depending upon which one you have, you may not be able to get something similar. This feed pipe down to the side, in some coaches, it's different here, so you'll need to check. But what is important is that I'm picking up cool air. Now, the radiator on the other side has a 50 horsepower fan. That fan is blowing air into this compartment. It's pressurizing it. When I would stop at a rest stop and leaving the system idling at, let's say, 1,000 RPM, and I'd open this, I'd be met by this massive blast of hot air. And this was one of the problems that other people had discussed with me. The factory decided that it was best to close this off, to add this. And because what was happening was, I believe, is that even though you had louvers that might try to bring air in, it couldn't compete, especially at low velocities, at low speeds, with the force of the air coming from the fan. And so hot air would come out and it would get sucked in the intake. Now that's been controlled. I made a very tight fit with a rubber seal here, so when it closes, it seals very nicely. And there's only one other open spot, and that's in this last spot, and I put in temporarily a foam fill piece, and it seals up very nicely. Now, whether or not the louvers help bring air into the duct, or because this entire area is open, whether or not air coming in here gets siphoned up towards the funnel, I don't know. But I do know I am getting a much better result. Now, one of the things that happened on the way from Phoenix to our first stop in Texas was we got slowed down quite a bit in Tucson. It was over 90 degrees. This was, I think, in April. And so what happened was we're crawling along at a lower speed and a lower RPM, which translates into a lower speed of air through the entire system. And I noticed that what normally we would see about a 40-degree rise in ambient temperature. I have an outside temperature gauge at the driver's station, and I would notice that my air intake was 40 degrees above it. So coming south to Tucson at 90 degrees, I noticed 130 degrees. When we slowed and we kind of crawled our way along for a while, I noticed a 20-degree increase in air temperature. And I think what was happening was the air was dwelling for a longer period of time in the system. So I had already, added insulation to the piece of aluminum pipe that faces the fan, because I know that was being heated by that. I had this here, but I had not covered the air filter. So I put a Dacron and there was a piece of insulating fabric we use that's kind of the thing you use on oven mitts, and then put this gold plated fabric on the outside, and it makes a nice insulated cover. So we did that, and the aluminum on the tube, the side tube, was already done. But this seemed to have fixed a bit of it. We noticed a drop in that temperature. So that if what's happening is that the air is dwelling for a long time, this is a very hot chamber. And as I said, we have a massive fan here, and it is just loading it. Now, if you look, you're in a really good position to see how much ventilation I have in the back. Well, it seems like a lot, but it's kind of a tortuous route through the louvers, and I don't think it's enough. It would have been much better to have some kind of ductwork inside that ducted the hot air away instead of shoving it up over the engine. Or, and I'm sure they can't do it, reverse the flow and just blow the air through the inside to the outside. That would have brought fresh air in everywhere and lowered the generic temperature in the back. Now, I don't think that's allowed, because if you were driving next to this, you'd be hit with this blast from the side. But that may be a reason why rear radiator installations may have a benefit. They're blowing it out the back. They're not keeping this air stifled inside. Now, in watching the oil temperature and the water temperature, I have a really good idea of what the norm is, and we do pretty well. When I'm going uphill and I'm really lugging, I do watch very carefully what the temperatures are. 188 degrees on the water is what I normally see cruising along without pulling a big hill. Once it gets up into the 200s, I start watching. At 210, I'll get a warning. It is not a Cat engine warning, it is a Silverleaf programmed warning. At 220, I believe, check, the Cat will begin to derate. It might be 230, I have to check that. Anyway, if you're watching and you keep up on this, you won't get behind the curve. This is like flying a fast airplane when you're dealing with the heat. You don't want to get behind the curve and let a lot of heat build up. You're going to have a hard time on a long pull to cool the system down if you've waited too long. Some of our oil is diverted to the centrifugal oil cooler, and that gives me the possibility of putting an oil cooler on the return line for that oil. So if I see that I have an issue, I have a venue for getting rid of a good amount of heat by doing that. So the other things which might affect this is the exhaust system, but there's not much I can do about it. The exhaust is buried in the back. It's all covered with heat insulation. There's a 6-inch set of pipes bringing the exhaust out. Some Newells will have 2 exhaust tips, but I don't know if there's a crossover and where that crossover happens. Some of the earlier semis had twin pipes for both intake and exhaust, and I could see that that would be a good way to deal with a proper air intake and exhaust system. With these tightly mounted 6s where the exhaust and the intake are all on one side, you don't have much option. You can only fit in what you can fit in. The good thing is this engine gives very good torque and very good power even at very low RPMs. The chart starts at 1200 RPMs and you're still getting 468 horsepower at 38 inches of boost. And then it goes up, 1300's 507, 1400's 546, 1500's 585, 1600's 603. So, you can kind of see why these coaches worked, even with this lousy intake pipe. Because until you get high enough velocities in that system, you get the air through. Even at low velocities, you get a lot of power and you get a lot of torque, which works for us. I had thought long and hard about whether or not it made more sense to build a much more efficient intake and exhaust system and control temperatures and put something like a C13 in here versus a C13. It's all moot now, but doing the same thought process with a Cummins. And I came away with the idea that no, the torque that this thing's putting out is really what is making this thing work. And so the loss of the top end, once the velocities in that pipe go to the point where the turbulence is collapsing the flow, wherever that happens, I think you're far enough along that you still got a working system. So I'm not sure I would recommend to everybody to just go in and do what I've done. By me turning the filter around, according to Raycor, I've added about 300 cubic feet per minute to the filter, which I think is important. However, there's also a correction I need to make. I had stated that the Raycor was the only filter rated to be run in reverse, meaning they had trialed it, tested it, and they say, okay, you can run it both forward direction and reverse flow. But that's not true, and somebody else caught me up on this. What it is that Raycor is the only filter that can do both directions on the same filter. There are some filters out there, but you have to read it carefully, that will run reverse flow. They're rated reverse flow, but they're not for doing forward flow. So that's helpful to know. The thing that I think I would recommend for people to look at is first trial, make sure that this also has this problem, that you see that high vacuum, and that you, depending on how much you want to do, you fix that 5-inch pipe. The best way to fix it, of course, is to come in there, put a 6-inch pipe to a 7-inch pipe. It may very well be possible that this pipe, which is a 90, could be turned into a 45 facing up, and then a 45 facing to this, blending in. So we might be able to essentially get rid of a 90, which would add another inch or so, or reduce it by an inch of vacuum. Remember, if you don't turn it around, this pipe is what you're feeding down. And the dangerous part, and I think this is important, is you do not want a straight run from the outside, an uncovered, unshielded inlet going right into the center of the filter. That's bad. So you have a couple of choices there. One, probably the simplest, is you can simply cut that pipe by possibly the 8-inch version pre-filter and some short sections of 8-inch pipe booting down to 7 at both the inlet and the filter. Let's see. Oh, here we go. The Donaldson Inline Separator, they call it, 7-inch, 1,400 cubic feet per minute, is model H001906. And the 8-inch, 1,500 cubic feet per minute, is model H001220. That will probably do okay. It works by getting the air rotating and spinning out both the dirt and the rain. They say 80% of the dirt will get caught by that device, so that'll give you a lot longer life on the filter. So, let's see what we've got. On the water cooling, heat management is pretty important, and you'll need to watch it. These engines do not, or at least none I've seen, they're not running above boiling point. You can get them above boiling point, absolutely, but most of the time you won't see that. There are a couple of things that I think in the future need to be looked at. One is this fan control. This turns the cooling fan on the radiator, either keeps it on low or keeps it up to high. There's 2 speeds. I think it may be possible to make a variable speed unit that actually saves you, might get 20 horsepower back into the system. And that's one area I'd like to look at. When it comes to the oil system, I had discussed last time that what tipped me off to the problem was an oil analysis which showed high silicon in the oil. At that particular time, I was experimenting with the Fleet Guard Combo Venturi oil filters. Now, let me see if I can find the model number. Here we go, LF9691A. So it's Fleet Guard Combo Venturi Loop Filter, LF9691A. And what it is the bottom section of that particular unit had a standard high bypass kind of filter, 30 micron size filter. But there was a secondary section which, since you turn it upside down, hangs off the bottom, which was a very high level filtration. I think they talked about 4 microns, but it looked tighter. Essentially, it was an origami folded piece of filter papers with some die-cut caverns in it that would allow dirt to build up in a fairly large quantity. And the oil would be first run through the high bypass filter, but some of that oil feeding to that would then go down and be run through the higher filter, so that every cycle through the filter, a certain percentage was run through this higher filter medium, and there was a Venturi system that preferentially added some additional vacuum or suction to that lower section to help oil move through that higher filtration. Anyway, once I had seen the silicon, not very long after that, I changed the oil, pulled the filter, and at the same time pulled a sample of oil. And what had happened was that filter was running during the time that rain had happened. But it wasn't very long. It was a very short time period. Essentially, that rain happened in northern Florida, and my next stop was Miami, Oklahoma, in the factory where they did a service. So that's, let's say a little over 1,000 miles. By the time I rechecked my oil, a couple thousand miles later, that filter had managed to clean up all the silicon. It was gone. Let's see if I got that right. We had the exposure in Florida. We read it. We read the bad report. I'll have to check on that. We read the bad report in Miami. We had things changed. No, that's right. So it had to clean it up. But essentially what had happened was that filter had in fact cleaned up the silicon that was in the system. I'm sorry, I need to work through how this went on. I didn't like I didn't care for certain features of that filter, even though it worked well. Their new one, essentially, it looks like a standard filter, built like a standard pleated filter, both for the high level and the low level filtration. It's just the high level has a higher density of filtration medium. Instead, I went back to the Cat, the 1R 1808s. I like those filters. It is the design for filter for this engine, and if one thing the Cat knows, it's how to run in a dirty environment. I gave the numbers last time of how much ingested dust is acceptable for this engine. It's 34.5 milligrams per hour per cylinder. That's a lot. Our existing numbers are more like 3.4 is what we ingest. So what I did was, as I said, I put in this centrifugal oil filter, which takes down to like 0.1 micron. And on top of that, I've tapped into the oil supply ahead of the oil filter. So I'm getting ahead of the oil filter and ahead of the oil cooler. which is the recommendation from the people who make this centrifugal filter. Get it as hot as possible, keeps it thin, allows you to get more dirt out of it, and then the higher pressure, in this case up to 90 psi, gets a higher revolution on it, you get more G-forces being generated, you get oil out, you get the dirt out of the oil faster. On top of that, normally a 2 gallon per minute filter would be used on this. I went down to 1 gallon per minute because I want the dwell time for that oil to be longer so I can get the smaller particles out with each pass. It's given me very clean looking oil. I'm pleased with it. So to give you some numbers before we move on, 5-inch pipe here, the feet per minute to move the proper amount of air is over 12,320 feet per minute. That's about 140 miles an hour. We know we're not getting it because you can't get it. 6-inch pipe is asking for 8,556 feet per minute. That's running 97 miles an hour. The 7-inch pipe is 6,286 feet per minute. That's 71 miles per hour. And I like that number because I can do 70 miles an hour in this coach. If I had a proper air intake system, and we could look at this and see, the 71, 72 mile per hour velocity on the air is something possibly attainable to use as inlet air pressure. Maximum velocity that Caterpillar would like to see you not go above is 2,000 feet per minute. It's very low. As I said, it takes a 12.5-inch pipe to deliver oil, to deliver air into the engine at that speed. The recommended air filter, I would say, is the Raycor 062891003. It's one of the Ecolite series. And the only reason I'm saying I like that is because it will do both directions of airflow. And it seems to be the only one where they've done a nice engineering when you look at the flutes inside. Typical new vacuum reading on that filter is declared somewhere between 5 and 6 inches of water. The filter minder that I use is a Donaldson X002275. That is a 30-inch range, 30 inches of water column range. And I think you'll need that if you're going to be doing any kind of looking at it. Especially if you hit a wet day, you're going to want to be able to go over 25 inches. Places to pick up both the tubing and the hose. There's three places I use. Intakehose.com was real good. Truck Pipe Store was another one, and M&D Distributing was another. I tested the Fleet Guard Combo Venturi at 5,516 miles. So that gives you an idea of how fast these things can happen. My initial concept was the filter was too small. I don't think that may be the case. My thought now is watch your finger. It's in front of the camera. The present thought is that the filter is marginally okay. By turning it around, I get a full 1,900 cubic feet per minute. If it's turned around the way it comes from the factory, you're already very light. You're at 1,600. So then it really does become marginal. Exhaust systems from Donaldson's engineers say that they think 3,000 cubic feet per minute is the maximum flow. Since it is not vacuum, it's pressure, it works. Whether there is something else to be done with it, a little bit more analysis. I know people were replacing the exhaust manifolds in these engines, trying to get some more horsepower, but I don't see any reason to replace the exhaust manifold if you can't get the air in at the other end. So you might think about that. There is no recommended maximum exhaust velocity from Caterpillar that I could find. So if you're going to do an air intake upgrade, here's some ideas. Only install the Raycor filter in reverse flow, if you're going to do reverse flow. Install a filter minder into the 5-inch pipe elbow to see what your numbers are. I would certainly trim. In my case, I didn't have the time and the ability to constantly take the vehicle out and test it to find a mountain. The long runs up to Flagstaff were too far for me to take it back and forth. If you have some way to test it quicker, it'd be nice to see the different variations, but by all means, get the 5-inch pipe trimmed. If you want to go to the next step, install a 7-inch or 6-inch combination 6-inch, 7-inch air ducts through the intake like I've done. I would certainly recommend either the centrifugal separator or some kind of air extracting, rain extracting scoop on the intake. I think it's pretty important. The Bluetooth vacuum gauge that I use that allows me to read the vacuum at the driver's position is important for me to see when it's happening. But for you, you might not think that's that important. All you care about is, are you hitting, what's your maximum that you're hitting? That's what you really care about. And the other thing that I think you do need to do, because I've heard this from many people, you do need to stop the hot air from coming out here and getting into the intake. So what Newell now does is the air intake to the filter comes from the roof. They've got a rectangular hole up here, so the ductwork comes down and into the filter, which I think is the best place to go. They don't have to worry about heat from anywhere now. Now, the other thing is that, and this helps to understand, the C15 vehicle gearing, the vehicle weight, they call out 80,000 pounds with 1,750 foot-pounds for an axle ratio of 1,400 RPMs at 65 miles an hour. Meaning if this were to weigh up to 80,000 pounds, which we fit into that category, then they're looking at an axle ratio to give them 1,400 RPMs at 65 miles an hour. So they're able to keep, and that makes sense because they want to keep the RPMs as low as possible and get the best mileage. However, when they go to 90,000 pounds, they have to gear 1,500 to 1,650 RPM to get 65 miles an hour. So they have to increase significantly the RPMs. So at our gearing where we're sitting, we should be able to hit around 1,400 RPMs at 65 miles an hour. Which at 1,400 RPMs, as I said, we're only looking at 546 horsepower with 44 pounds of boost. All right, we've discussed everything else. Okay, so that's my conclusion. I think this system now works. I think insulating the pipes was a good thing to do. I think I can still gain some additional function by cleaning up this beginning end of the pipes and getting rid of one of the elbows. I still need to get onto a really long 6% grade. That'll really show what I've done with this and whether or not I've got it nailed at this 12 inches. If I can get on a dyno, I'll certainly make another video about it because I think it's worth doing. And I'd really like to hear back from other people, even if you don't have a Cat, even if you don't have a Newell. This pusher style installation of big diesel engines are prone to these kinds of mismatches and misdesigns, so I'd like to hear about it. And that's it. Thanks.